carbonate will give 2 times 2, 23 plus 1 plus 12 plus 4 times 1, which will give us 168 grams. Mass of 1 mole of carbon 4 oxide will give us 12 plus 16 times 2, which will give us 44. Mass of 1 mole of sodium triiosocarbonate will give 23 times 2 plus 12 plus 48, which will give us 0.106 grams. Thus, 106 grams of sodium hydrogen triiosocarbonate when heated produce 44 grams of carbon 4 oxide. 8.4 sodium hydrogen triiosocarbonate when heated produce 44 grams of carbon. 44 over 168 times 84 over 1 gram of carbon 4 oxide will give 22.2 grams of carbon 4 oxide. The residue left after heating sodium hydrogen triiosocarbonate is sodium triiosocarbonate, which not affected by heat. Thus, 168 grams of sodium hydrogen triiosocarbonate when heated produce 106 grams of sodium triiosocarbonate. 8.4 grams of sodium hydrogen triiosocarbonate when heated produce 106 over 168 times 8.4 over 1, which will give us 5.3 grams of sodium triiosocarbonate. 5.3 grams of represents the amount of sodium triiosocarbonate to which hydrogen chloride was added. Hence, sodium triiosocarbonate react with dilute hydrogen chloride as followed. Sodium triiosocarbonate plus hydrogen chloride to give sodium chloride plus carbon 4 oxide plus water. From the equation, 1 mole or 106 grams of sodium triiosocarbonate produce 1 mole or 44 grams of carbon 4 oxide. Therefore, 5.3 grams of sodium triiosocarbonate produces 44 over 106 times 5.3 over 1, which will give us 2.2 grams of carbon. Example 4. What mass of dilute triosonitrate 5 acid containing 10% weight per weight of pure acid, while being required to dissolve 2.5 grams chalk calcium triiosocarbonate? Solution. Equation of the reaction: calcium triiosocarbonate plus triosonitrate 5 acid give calcium triosonitrate and water and carbon 4 oxide. 1 mole of calcium triosonitrate combines with 2 moles of triosonitrate 5 acid, or 100 grams of calcium triosonitrate carbonate combined with 126 grams of triosonitrate. Thus, 1 mole or 100 grams of calcium triosocarbonate are dissolved by 2 moles or 126 grams of triosonitrate, the triosonitrate 5 acid. Therefore, 2.5 grams of calcium triosocarbonate will be dissolved by 126 divided by 1 times 2.5 divided by 100, which give us 126 times 0.25, which will also give us 3.15 grams of pure acid. 100 grams of pure acid is contained in 100 grams of dilute acid. Therefore, 3.5 grams of pure acid is contained in 3.15 times 100 divided by 10 grams of the acid, dilute acid, which will give us 31.5 grams of the dilute acid. Example 5. Calculate the mass in grams of copper that will be deposited by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6 solution. Solution. Equation of the reaction. Zinc reacts with copper tetraoxosulfate 6 to give zinc tetraoxosulfate 6 and copper. That is 1 mole of zinc reacts with 1 mole of copper tetraoxosulfate 6. Or it says 65 grams of zinc reacts with 63.5 grams of copper tetraoxosulfate 6 in gram. Therefore, thus, 1 mole of 65 grams of zinc displaces 1 mole or 63.5 grams of copper. Therefore, 6.5 grams of zinc displaces 63.5 divided by 1 times 6.5 for the zinc divided by 65 grams of copper. This will give us 6.35 grams of copper. Example 6. On heating 5 grams of hydrated copper tetraoxosulfate 6 of constant mass 3.20 gram and anhydrous copper tetraoxosulfate 6 were obtained. If the formula of the hydrate is CuSO4SH2O, calculate the value of X. Solution. Tetraoxosulfate 6 crystal will dissociate to form copper tetraoxosulfate 6 plus water crystal. Mass of the hydrated salt, which is copper tetraoxosulfate 6 X hydrate, is 5 gram. Mass of anhydrous salt, which is the copper tetraoxosulfate 6, is 3.20 gram. Therefore, mass of water will be 5, the mass of the hydrated salt, minus 3.520 mass of the anhydrous salt, which will give us 1.80 gram. Therefore, molar mass of copper tetraoxosulfate 6 will become 63.5 of copper plus 31 of sulfur plus 64 gram of oxygen, which will give us 159.5 gram. The molar mass of water is 2 for hydrogen plus 16 for oxygen grams, which is 18. 3.2 gram of anhydrous salt converted into moles will now be equal to 3.2 gram. That is the mass of anhydrous salt divided by the molar mass of the anhydrous salt, that is copper tetraoxosulfate 6, which is 3.2 divided by 159.5 moles of salt. Then 1.8 of water is equivalent to mass of water, which is 1.8 over the molar mass of water, which is 18 moles of water. Therefore, the ratio of moles of the anhydrous salt will now be equal to 3.2 over 159.5 for the anhydrous salt is to 1.80 divided by 18 for the water, which is in the ratio of 0.02 is to 0.1. That is equals to 1:5 ratio. Therefore, the anhydrous mass of the S or of the crystal is 5 atoms. Chapter 6. Boyce, Charles, general gas equation and Dalton's law of partial